Good morning, everyone. The content of my presentation today is the attributes of rational function. There are many attributes of rational function. Letter A, the vertical asymptote. Letter B, the domain. Letter C, the horizontal asymptote. Letter D, letter D, range. Then E, x-intercept. F is y-intercept. Letter G, the behavior of the graph as x approaches to the vertical asymptote from the left and from the right. There are many attributes of rational function. That's why my presentation is lengthy, and I divide my presentation into two parts. The first part is vertical asymptote and the domain, then the horizontal asymptote, and the last is the range. The range. So let's start with the vertical asymptote. The vertical asymptote VA x equals A. It is a line x equals A that as x approaches A from the left, in notation we have x approaches A from the left is the notation, or from the right. So the notation is x approaches A from the right. The f of x or y increases without bounds. It is in notation also. The y increases without bounds, or f of x equals y, or y decreases without bounds. That is in notation y decreases without bounds. Example. Our example is f of x equals 3x over x plus 3. To get the vertical asymptote, we equate the denominator to 0. Why? Because we are going to get the value of x that is not part of the domain. So we equate the denominator to 0 here. X plus 3 equals 0. And we get the value of x is equals to negative 3. This is our x equals negative 3 is our vertical asymptote. And x equals negative 3 is not part of the domain. Why? Because that comes from the denominator. X plus 3 is the denominator. And if we plug in negative 3 to x in the denominator, the denominator will be 0 because negative x plus 3 is 0. And that is what we avoid. We avoid the denominator to be 0. Okay, so x equals negative 3 is not part of the domain. So from here, we can already identify the domain. So the domain is, in notation, we have x, the domain are all x such that x is not equal to negative 3. Because the domain are all x, here except negative 3. That is in set notation. Or you can also name the domain through interval notation. That is negative infinity, parentheses, to negative 3, excluded. This is union. That should have been u. This is u. And negative 3 excluded to positive infinity. That is in interval notation. So that is our domain. In getting the vertical asymptote, VA, x equals a, and getting the domain, they should be the first, they should follow each other because they are related, closely related, the vertical asymptote and the domain. Because once you get the vertical asymptote, you can already get the domain. So that is for vertical asymptote and the domain. Now, we'll go to letter C. The letter C is the horizontal asymptote, another attribute of the rational function HA, or that is y equals b, no, in general term. In getting the horizontal asymptote, there is a rule. The rule is, let n be the degree of the numerator and m be the degree of the denominator. So n, degree of the numerator, m, the degree of the denominator, and a, the leading coefficient of the numerator, and b, the leading coefficient of the denominator. So, we have sub-example, 3x squared plus 2x plus 6 over 2x cubed plus 3. From here, we will label n, m, a, and b. So, n here is the leading coefficient, the degree of the numerator, that is 2. And m is the degree of the denominator, that is 3. And a is the leading coefficient of the numerator, that is 3. And b is the leading coefficient of the denominator, that is 2. Okay. So, this is just used for labeling n, m, a, and b. Okay. But, this is not a function we are studying. So, let's have the rule. If n is less than m, the horizontal asymptote HA is y equals 0. M is less than m. Y equals 0 is the horizontal asymptote. Second is, if n is equal to m, the horizontal asymptote HA is y equals a over b. And the third one, because there are three cases, the third one is, if n is greater than m, If n is greater than m, there is no horizontal asymptote. So, going back to our function under study, you have f of x equals 3x over x plus 3. So, we label n, m, a, and b. Our n is the degree of the numerator, that is equal to 1. Our m is the degree of the denominator, which is equal to 1. Our a is the leading coefficient of the numerator, that is 3. And our b is the leading coefficient of the denominator, that is equal to 1. Because if the variable has no number, that's understood to have 1. So, the horizontal asymptote HA is y equals a over b since n is equal to m. So, our horizontal asymptote is a over b, and our a is 3 and our b is 1. So, we have 3 divided by 1 equals 3. Or, y equals 3 is our horizontal asymptote because n is equal to m, I repeat. Okay. And y equals 3 is not part of the range. Y is equal to 3 is not part of the range. So, from here, we can already get the range. The range is, so that is our letter D. The range is the set of all y such that y is not equal to 3. That is in set notation. Or in interval notation, we can name it also as negative infinity parentheses to 3 excluded union 3 excluded to positive infinity. So, we got the 4 attributes of rational function, and that is the first part of our presentation for the attributes of the rational function. Good morning again, and shout out to everyone, especially those who subscribe and view.